ANOVA, that is one-way ANOVA, and along with ANOVA, we will discuss all the aspects like one-way ANOVA we discussed yesterday a little, and today we will expand it. And if the time will permit, I will introduce
One-way
about
ANOVA, and along with ANOVA, we will discuss all the aspects like one-way ANOVA we discussed yesterday a little.
I'm listening back my voice. Can you please?
Yes, sir. Yes, sir. We
take
are
care of
also. Sir, Abhilash, sir.
Okay.
Sir, you now you go on, sir.
Okay,
Sorry for
fine.
the inconvenience.
No,
Sir.
no, no, it's okay.
Thanks.
So we will discuss about the ANOVA in detail, right?
Madam?
Sir, you now you go on, sir. Sorry for
Okay,
the
okay.
No, 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 it's okay.
All right. So
We will discuss about the ANOVA in detail, right?
Sir,
again, it
எங்களுக்கு
is
repeated கேக்குது, sir. Abhilash, sir. Ma'am?
What, Sonia?
Ma'am, again we are hearing whatever sir have told in the previous, ma'am. அதுவே தான் repeated கேக்குது, ma'am. What sir is now is going to tell, அது
Sir
கேக்கல,
is
ma'am.
not telling anything now.
Right now he is not telling anything, but previously the voice we heard, ma'am.
But now it will be over, ma'am. It will be over.
Okay, ma'am. Sir, you can start, sir.
all right. All right.
You can start, sir. Soon. It's
Yes, yes, I'm starting.
It's live now.
Okay. So I will share the screen and then I will start with the data and that we discussed yesterday, and even today we will discuss about some more data.
Yes, sir. You can share the screen.
Yeah, I'm sharing. Just give me 1 minute. Okay, I'm sharing the screen. My screen is visible?
Yes, sir.
Okay, now let us take up the cafe data that we were discussing yesterday. Okay, so I will repeat the ANOVA, that is one-way ANOVA. Now, what is our purpose of applying one-way? Okay, so I'm making some notes simultaneously. My word file is visible?
Yes, sir.
Okay, now there are few things like compare means. Okay, so we compare mean in many different senses. So we compare mean like single mean. Single mean means one variable, right? Which is metric, because mean can be calculated in metric only. In categorical variable, we cannot calculate mean, because suppose there is gender. Okay, so in gender, male and female, we cannot calculate mean. That makes no sense. Okay, so suppose there is a metric variable, single variable. So we have a single mean value. So how do we compare a single mean value? Only we can compare it when I think I should minimize it. Only we compare it with the test value. So we compare it with the test value. When we compare it with the test value, which test do we apply? We apply one sample t-test. Okay, so this we did yesterday. So one sample t-test we apply. All right. When we have two means, right? Which means we have two variables, both metric. Okay. Not two variable. We have two variables, not both metric. IDV is categorical. And just give me 1 minute only. Ma'am, can you give me just 5 minutes? There is some urgent call. Just 5 minutes.
Okay, sir.
Thank
Okay,
you.
sir.
So nice of you. Yes, I'm back. I'm so sorry for the inconvenience.
No
Am I
problem, sir.
audible?
Thank you.
Okay, thank you. So it is important to learn where do we apply which statistical tool? Maybe I will be repeating again and again because this is extremely important. So when we have two means means they are classified based on categorical variable. Like male and female. So male and female, there are two bisects of the one variable. One variable has been divided into two. So we have two means. Okay. I'm deleting this. So one IDV is categorical and DV is metric. Maybe interval or ratio. So we compare means with each other. Okay. So mean of males compared with mean of females. Okay. All right. Now, which tool we apply? It is independent sample t-test. Okay. Independent sample t-test, two samples. One is male and one is female. All right. Now, the same situation, I copy and paste. And here, I compare high income, low income, medium income, and low income. Okay. And I apply ANOVA, which is one-way ANOVA. Why it is one-way ANOVA? Because one-way ANOVA deals with one independent variable. Okay. But here the categories are more than two. So here we have more than two means. Okay. All right. So we have more than two means, right? Classified based on the categorical variable, which is rather than male or female, we have high income, medium income, and low income. Suppose we have three means, more than two, maybe 3, 4, 5, 6, whatever. Okay. Right. So we will compare IDV is categorical, that is income, and DV is metric, that is maybe an interval scale, interval or ratio. It may be ratio also. Oh, so sorry, I have already written it. Interval, comma, ratio, interval, comma, ratio. All right. So this is the way that we can do. Right. So this is independent sample t-test, and this is one way ANOVA. The difference is only the number of categories in the independent variable. Here there are two categories. Here there are more than two categories. Like more than two means, because there are three categories, so there will be three means. So we compare with one-way ANOVA and post hoc test, which is called, say, Tukey HSD. That Tukey HSD is post hoc test, which is highly recommended. There are others also, LSD also, but I prefer HSD because HSD is a better test, which honestly significant differences are detected by this test. Okay. So now we will look forward. First, we will see our data, and then we will go forward for applying this statistical technique. Okay. So when we see the data, that data I also discussed yesterday. This is the cafe feedback data. Okay. Now I open this cafe feedback data. All right. So I have ambience, food quality, staff behavior, timings, price, credit terms. All are dependent variables. Okay. Now just always do not think that these are many variables. In ANOVA case, ANOVA will be calculated separately for ambience, separately for food quality, separately for staff behavior. separately for timings, price, and credit terms. It will be separately calculated. It will not be calculated in a way like it will not be calculated combinedly for all. Okay. So that is why we call one dependent, one independent. Okay. One independent, one dependent. So we have three categories in income, and let us take all of them together just to, but calculate separately. So there will be 1, 2, 3, 4, 5, 6, 6 significance values. That whether the impact of income is significant on ambience, whether the impact of income is significant on food quality, whether it is significant on staff behavior, and so on. Now, how do we develop the hypothesis? So, hypothesis development for ANOVA. In case of ANOVA, it is done like the null hypothesis is there is no difference between the satisfaction of students for difference among various income groups for the satisfaction of students for quality of food. For example, so you make separate hypothesis for, say, quality, price, everything. There is no difference among. There is no difference in high income, medium income, high income, low income, medium income, low income, all three categories, all three combinations. Okay. Alternative hypothesis is there is a twist. There is a significant difference. If I write among various category income groups, now it means that all the income groups must be different, which is may be possible, may not be possible. So even if one group has significant, like let me write here, high, medium, and low. Okay. So we are comparing high with medium, high versus medium, medium versus low, and low versus high. These are our comparisons. Even if one is significant, this is a significant, suppose, and this is not significant, this is not significant, the ANOVA value would come significant. Okay. The ANOVA significance will be significant. Okay. But we cannot say that all are significant because all are not significant. This we will come to know by post hoc test. So we make a hypothesis. There is a significant difference between at least two income groups. At least two income groups are significantly different. So it fulfills the purpose of alternate hypothesis for the satisfaction of the students for quality of food. Am I right? If you have any doubt, you can ask. This is different from t-test because in t-test we have only two groups. So there are two combinations. Here there is only one combination. Sorry, in t-test one combination. Okay, I can write here also. There are only two groups, so they can be compared like class. So if we say combinations, so there is one combination. And here there are three combinations. So one-to-one comparison is not required because there is only one combination. So whatever significance comes is for that only. Here, whatever significance comes, we don't know with which group it belongs to. It belongs to one combination, two combinations, or all three combinations. For that, we apply post hoc test. But even if one is significant, our purpose is fulfilled for the alternate hypothesis. So there is a significant difference between at least two income groups for the satisfaction of students for quality of food. This is the only difference while we form an alternate hypothesis for ANOVA. Okay. Is it clear, or you need any clarification, any questions, any doubts? You can ask.
So no questions.
Clear,
Sorry?
sir. It's clear,
Okay.
sir.
Thank you. Thank you. Thank you. So now we go to our spreadsheet, which is an SPSS spreadsheet. In this, we see that income is our independent variable and all these are our dependent variable. Okay. So I'll go to analyze. In analyze, we have compare means. Okay. In compare means, we have one-way ANOVA. Okay. So we click on one-way ANOVA. Okay. Then we select all of them in the dependent list. So we put all of them in dependent list, like feedback of students for like what we can do is and income is the factor. Factor means independent variable factor, and we click OK. All right. So now what does it show? It shows that there is a significance, there is an ANOVA value, there is a degree of freedom, mean square, F is the ANOVA value, sum of squares is there, and then we have significance. So I have a YouTube channel. I have my video on one-way ANOVA, which is computed through Excel, through the formula, following the formula. And then I compared the results with SPSS. I can send the link to Professor Radha, and then she can further share. So I have a YouTube channel, and you can share that channel with the students also. I keep on uploading videos on factor analysis, regression analysis, and many other statistical tools.
Sure, sir.
I have covered both. Yeah, I have covered both one-way ANOVA and two-way ANOVA. Both I have covered. Okay, and even I can cover things on demand also. Suppose your students or your faculty want like we need more information on this, I can make a video and upload. Okay. So we see that the last column shows the significance value. So for feedback of students for ambience is significant. Sorry, not significant, because the value is above 0.05. Okay. Significance means significant difference is denoted when value is below 0.05. Okay. So not significant. Simply the food quality not significant, staff behavior not significant, timings not significant, price significant. It is 0.05. Okay, let us compare. For price it is 0.005. We are taking 0.5. It is 0.005. So of course it is below 0.05. So it is significant. Okay. Price is significant. Credit terms not significant. It means that income affects price significantly. So we accept the the alternate hypothesis in case of price. So we can copy this and we can write here price. For price it is, this was just an example. We need to make all hypotheses for all, and we accept for others except the price. So there is a significant difference between at least two means, two income groups. So far with this table, can you tell me, with this table, do we know which groups are different? No. This is in totality. In totality, price significant, but we don't know whether this difference is between the low income group and high and middle income. Isn't it? We don't know about it. So to know it, we will apply post hoc test. Now we will apply post hoc test only for price because others are not significant. So there is no meaning to apply. Others are not significant. So there is no use of applying post hoc except for the price. So let's do it. Analyze, compare means, ANOVA, one way ANOVA. This is one way to go to the statistical tool in SPSS. Other ways, there is a smart tab here. Recall recently used dialogues. You can click on this and your 10 recent tools will be here. So you can click from this window also very quickly. So this remembers what I have done. And now I go to post hoc, then click on Tukey, only Tukey, TUKEY, continue, okay. So this will calculate the whole ANOVA for me again and will give the post hoc tests. Post hoc test Tukey HSD, right? So I have calculated it for all. Let me calculate it for price only. So I can let others out and calculate for price. So this is the final outcome. I copy it and paste it here. Okay. So that I can do some operations with it. Now, these are the combinations. Let me make a table so that it is good visible to all of you. Now you see, the most important is significance. Okay. You see that I color it red. You forget about these, everything, mean difference, standard error and all. Only categories 1 and 2. Suppose 1 is the category for high income. 2 is the categories for middle income. And 3 is the category for low income. So suppose we see here, high income and middle income show a difference, okay, which is significant, below 0.05, which shows there is a significant difference between high and middle income category. Rather, high and low income category is not significant difference. But what about other? High, middle and low. Middle and low we can see 2 and 3. 2 and 3 is middle and low. Very close to each other, but not a significant difference. 0.05, it is more than 0.05. Okay. 0.8. Right. Right. Correct. So, any doubt in this?
No, sir, it's clear.
No, sir.
Okay, thank you. So, this is the interpretation. Now, there is only one small significant difference found in the whole of the data, but that should be, if it is useful for your research, your objective, it is matching to your, the hypothesis, your main purpose of the study, it is very, very useful. Okay. Now we see this is done. All right. So this was the example of one-way ANOVA, which we have done practically by making the formulating the hypothesis and all. Okay. So if you need another example of one-way ANOVA, we can do one more example also. Let me find out some data. This is a two-way ANOVA data. So I'm just finding. I'm closing this cafe data. Okay, I don't want to save the output. Say no. All right. So okay. Now this is some data which is related to two-way ANOVA, and we can use one-way ANOVA also from this data. So let us do, we'll practice both because somebody requested for two-way ANOVA yesterday. So I thought of giving some, time to two-way ANOVA also. Am I audible?
Yes, sir.
Just checking in between.
No
Yes, sir.
problem.
It's audible only, sir.
Hello,
Yes, sir. It is
It's
audible.
audible to us,
am I
sir.
audible?
Yes, sir. Yes, sir. Sir, do you hear me, sir? It's audible only for us, sir.
No?
No, it's audible only, sir.
Sir, you can continue, sir. It is
Hello,
audible.
am I audible? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir. I'm audible for you.
Yes, okay.
Yes, sir.
All right. So now on your screen, this file is visible, territory, sales, advertising, and season.
Yes, sir.
Yes, thank you. So when we see the variables, let us first identify which variables are categorical and which are the factor, which are dependent and independent variables. Now we see that territory is a categorical variable, territory 1, territory 2, territory 3. Sales and advertising is a metric variable which is on ratio scale. Season is also a categorical variable. So now let us go to our word file and make some new column for two-way ANOVA. So what is the difference between one-way ANOVA and two-way ANOVA? Let's say more than 2 means it's more than, it's a, let me delete this. Classified based on the categorical variable? Yes. So we have sales territory, and what do we have? Season. Okay. Sales territory and season. So in this we have independent variable which is categorical, dependent variable which is metric. Compare means with each other. Of course, we are comparing. But now the difference here is there are two IDVs, two independent variables, and dependent variable is 1. So dependent is 1 in all cases. Compare means with each other, and this is say two-way ANOVA. Let us not write about combinations here. Two-way ANOVA, which means combined effect of two independent variables. Combined effect of two independent variables. Okay. Combined effect we write like this also. The notation is territory star season. This is a notation that we write the combined effect. So before we take a combined effect, let us apply one-way ANOVA on both. So we can apply a one-way ANOVA on. I go to one-way ANOVA. Territory is my independent variable or factor. Sales and advertising are the dependent variables. I want to see whether the sales and advertising differ based on the territory. Okay. Okay. This is the result, and both the results are insignificant. So based on territory, the ANOVA is the sales and advertising do not differ. Sales and advertising, they do not differ based on the territory. Okay. That is same. Am I right? Because this is above 0.05. This is what our criteria is, right? The significance value is above 0.05, hence no significant impact of sales, no significant impact of advertising territory on sales and advertising. Okay, not combined, separately. Neither on sales nor on advertising. There is no impact. Okay, let us test it for. Let me. Test it for seasons, whether the advertising and sales vary as per the season. So we apply one-way ANOVA, territory will be out now and season will be in. Okay, and okay. So here also I do not find any significant difference. There is no significant difference between same case. The significance value is above 0.05. So there is no significant difference. All right. Now, let us talk about the combined effect of. Now, prima facie, we can say that if one-way ANOVA is not significant, the two-way ANOVA will also not be significant. This we can say primarily, but it is not true always. Let us apply the two-way ANOVA, and two-way ANOVA means, two-way ANOVA simply means impact of two or more independent, two I must write, otherwise it will be one n-way ANOVA, impact of two independent variables on dependent variables. Okay, so that will be separately calculated, right? That will be separately calculated, but we write it in a way that there are two independent variables. Now, two-way ANOVA will be found in general linear model, analyze tab, general linear model, univariate. Okay, not multivariate, but univariate. So analyze general linear model, univariate. In univariate, you have a box like this. So the fixed factors are territory and season. These two are the factors. The dependent variable is this. So you can't put this. You have to check them one by one. Okay. You have to check. Otherwise, you'll have to go to multiple or multivariate model. This is a univariate model, so you have to check one by one. So let us first check sales. So these are two fixed factors and this is sales. So these two fixed factors will combinedly let us know about the covariate. Is again, if we have a metric variable, then we put it into covariate. There is no covariate, so we say okay. So now there is a result like this, the intercept, territory and all, territory and season. Okay. Now let us copy and paste it here. It comes significant or insignificant, that doesn't matter. What matters is we should learn it. Now this is the result basket. In the basket, important for me is these three things. Okay. These three things are important. What is the first? First is territory, which is insignificant. You see 0.159. Season insignificant. Territory into season is insignificant, 0.836, which means there is no significant difference of both variables put together, combined. Even if we take them combined, there is no significant difference. Okay. So this is the answer of two-way ANOVA basically. This line, territory star season. So territory multiplied by or territory into season is coming insignificant. Okay. And that is the bottom line. All right. So is it clear to all so far? Now let us check it for advertising also. So I take out the sales out and put in the advertising and okay. Now again, almost the same condition, but there is a very interesting interpretation, very interesting output. You see, this sum of square in the type 3 sum of square, this is a model named model type 3. You see, territory individually explaining 0.646, season explaining 648, and when territory and season put together, they're explaining 25.168, which is more. And even if you see the significance values, for territory it is very bad, season it is again not very good, but for territory less value is good in significance now, because we are in search of below 0.00, 0.05. It is much better, which means that territory and season put together they affect the advertising, but not to a very good level, not to the significance level, but they improve. If they are put together, they improve the results. However, here the results are deteriorating. The results are very good with the territory, but they are very bad with the territory and season. The value is high. Okay. So this shows how we use the two-way ANOVA. So again, I repeat, a two-way ANOVA is when we have more than one or we have two independent variables and both are non-metric variables, categorical variables. So now I request you to ask questions before proceed further. Any questions?
Sir,
Yeah.
I'm Gayatri from Accounting and Finance, sir. So here, I didn't clear with the concept. No more doubts. But more than 2 means we can't able to use, isn't it, sir?
Yeah. Let me tell you. We can use it for more than 2 also. Okay. But only the name will be different. Then we will call it N-way ANOVA. Okay. then we'll call it.
So in ANOVA, we can use one way, that is one independent, we can use it, isn't it, sir? So otherwise, two independent we can compare.
Two independent we can compare, three we can compare, three we can use. Like suppose in
We can compare.
univariate, yeah, I have one more variable, I can put it here. Okay. So
Oh.
even there 1, 2, these are independent. Factor means independent.
Yes, yes.
Dependent is clearly mentioned, but dependent cannot go simultaneously. For that, I need a different model. Okay.
Okay, so in this way, we can change the territory as a dependent variable, and other three we can use it as a independent variable.
No, ma'am. No. Because we are not looking impact on territory. We are looking impact on sales.
Sales and advertisement. Yeah. Now I can understand, sir.
This
Yes.
is not independent, dependent.
Based
See,
on these two only, we have to update the
based
sales.
on your theoretical model, like theoretically, we say that sales is dependent, territory is not dependent. And one more thing, in the dependent, let me show you. In this dependent category, only interval scale or ratio scale will be applied. Categorical variable will not be applied, like gender, territory, season, income levels, male, female, skilled, unskilled. That will not come in the dependent.
Dependent variables. Yes. Yeah.
Will be
I can.
only independent. Okay.
Yes, sir. Thank you, sir. Thank you, sir.
Welcome. So let us take a quick, recap of what we have done today. So what we have done is we started with this table. So we have to be very clear about the dependent and independent variables measurement. Okay, this measurement is very important. If one IDV, so I must write here, if this is 1, okay, and DV is also 1, this will have to take care of. Both should be 1. Here we are dealing, this is also 1. Now, even if I apply here, say 4, 5 DVs, but they will be separately calculated. They will not be calculated in combination. So both are 1. The categories are more than 2, like high income, medium income, and low income. Here the categories are, categories are more than 2. Here the categories are only 2, male and female. This one difference, this is the major difference. See, this one difference changes the statistical tool. 2 categories, 3 categories. So this changes independent sample t-test to one-way ANOVA, and post hoc test is also required, because here there is only one combination, male versus female. Here there are 3 combinations, which I have written here. Okay. These are the 3 combinations. High, medium, medium, low, low, high. 3 combinations. If there are 4 categories, suppose 4 categories, we will apply ANOVA. The combinations are 1 versus 2, 1 versus 3, 1 versus 4, 2 versus 3, and 3 versus 4. Okay. Am I missing any category? 1, 2, 2 to 3, 2 to 4, 3 to 1. Yes. 1 is there. 2 should be there. I think 2 to 4. 2 versus 4. Yes. So how many categories do I have? 1, 2, 3, 4, 5, 6. There is a formula also for calculating the combinations. So if I have like 2 categories, I have how many combinations? 1 combination. If I have 3 categories, I have 3 combinations. If I have 4 categories, what is category? Category means male, female, skilled, unskilled. Okay. 1, 2, 3, 4, 5, 6 combinations. I avoid ANOVA. I avoid making more than 4 categories, because if in our questionnaire we make more than 4 categories, the calculations are very cumbersome and very, very difficult to handle. The tables are huge. The handling the data, handling the analysis is very, very difficult. Okay. So that's all from my side today. If you have any questions, you can ask. I have covered one-way ANOVA and two-way ANOVA. Tomorrow we will see factor analysis. Okay. Any questions, any doubts, any feedback you can give me.
Sir, I thought there is no any doubt because the section was very clear to everyone. And the feedback is everyone is saying is in a good one, sir, because you are giving a more informative to us.
Yes,
So apart from that, there is no any doubt question. So thank you for the informative and the effective session, sir. Really, thank you so much.
Okay, thank you so much. I will share the YouTube channel link also.
Sure, sir. We are waiting for it.
Thank you so much.
Thank you, sir. Thank you, sir.
Thank you. So kindly allow me to wind up for the day. Okay.
Sure, sir. Sure.
Thank you, sir.
Thank you.
Ma'am?
Thank you, sir.
Thank you, ma'am. Thank you.
Thank you, sir. Thank you for the session.